Section 6.1, solving systems of equations. All right, before we even begin this, let's just ask ourselves, what comes to mind when you think of the word system? Some people may think PlayStation system, right? And, all right, what else could you be thinking of? Maybe you're thinking of the human nervous system, right? Or possibly a car stereo system, right? So what do all these things have in common, besides that they have the word system in there, is that there's many parts working together, right? Like what is a car stereo system? Well, it has a stereo, it has the woofer, actually you could tell you right here, the speakers, 2 super tweeters, 4-channel amp. So there's many things working together. A PlayStation, you need the console, you need the controllers, you need the TV. There's many things working together. The nervous system, obviously it's many things in your body working together that produce the nervous system. So the word system implies that it has many things working together. So let's now apply that to system of equations. What is a system of equations? It's simply 2 or more equations working together. So we need to find, on this section, we're going to be solving systems, and it's not just one equation, it's 2 or more. But in this section, we're only doing 2 at a time. 2 equations is a system, and we need to solve those. So we have this handout, and there's a class opener on this handout to help us understand how to solve systems. So number 1A, it says, what is a solution to an equation? Now, here's an example of an equation, x plus 1 equals 3. What would the solution to this equation be? Well, everybody should know that the answer, the solution to this equation, is 2, right? Why is it 2? Because 2 plus 1 equals 3. So what is the solution? It's the value, let me bring it over here, the definition. It's the value that makes an equation true. Right? Now, so it can't be 4 because 4 plus 1 is not 3. It's the value that makes an equation true. So it has to be 2. 2 plus 1 equals 3. It works. So what is a solution to an equation? It's the value that makes it a true statement. Let's move on to 1B. It says, name 3 solutions that work for this equation. Okay, so if we compare the first equation, the first example I gave you, it has 1 letter, just a variable x. The second equation has 2 variables, x and y. So name 3 solutions that work. 3 numeric or 3 pair of numbers that you could plug in here and here that'll make it a true statement. So some of us will be thinking, okay, how about 1 and 2, right? 1 plus 2 equals 3. Now instead of writing x equals 1 and y equals 2, let's write it in the form of a coordinate, because we know that coordinates really are x and y values. So we don't have to deal with x equals and y equals. We could just write it 1, 1, 2, that's an ordered pair, and that is a solution. But it's not the only solution. You could even switch the 2 and the 1, and that would be an answer as well. X could be 2, y could be 1, or maybe you could have x being 3 and y being 0, okay? Or you could switch it, but we have 3 solutions right there, and there's truly an infinite amount of answers. Let me just show you, let me keep going here. It could be 4 and negative 1. Because if I plug in a 4 plus negative 1, that'll give me 3. Or it could be 5 and negative 2. Or it could be 6 and negative 3. Or it could be 10 and negative 7. Or it could be 100 and negative 97, right? And you could keep going forever. Not only that, you could even do decimals, right? That's pretty crazy. You could say 1.5 and 1.5. $1.50 and $1.50 is a total of $3. So there's truly an infinite amount of answers. You can't write down all the answers that exist to this equation because there's an infinite amount of answers. I would like to just move on to this next, actually jump to the graphing part. As you can see, we have x plus y equals 3 right here. And this is the same graph, or the same equation, x plus y equals 3, and they want us to graph it. So when I graph, we already know how to graph with y equals mx plus b. All you have to do is get y by itself. So let's get that x by itself by subtracting x on both sides. And I will have y equals negative x plus 3. Now, now that it's in slope-intercept form, I know that my slope is -1/1 and my b value is 3. So let's graph this. It crosses at 3 because the b value is 3. Now from that point, I'm going to go down 1/1. So down 1/1 and put the coordinate right there, or put the dot right there. Down 1/1, down 1/1. And I could keep going forever and in the opposite direction as well. So there's my graph. There's my line. And let's go back to number 2a. It says, when you graph an equation, we just graphed it. What does that line really represent? This line, the reason why we put arrows is because it continues forever and ever and ever. And as you could see up here, we came up with 3 solutions. We came up actually with more than that. There's an infinite amount of solutions. And if we think about the answer 1, 2, 1 for x, 2 for y, that's a solution. And if I go over here to the coordinate 1, 2, that's a point on the line. If I go to 2, 1, 2 on the x, 1 on the y, it's a point on the line. If I go to 3, 0, 3 on the x, 0 on the y, it's a point on the line. If I go to 4, -1, 4, -1, it's a point on the line. Even if I go to the decimals, 1.5 and 1.5, 1.5 right there, and then 1.5 right there, it's a point on the line. So what does this line really represent? It represents the infinite amount of answers that exists to this x plus y equals 3 equation, right? How many answers are there to this? An infinite amount. This line represents it because the line continues to go forever. Even if you were to go to 100 and -97, think about that. You would go 100 out this way and then -97 down this way. It would land perfectly on that line, okay? So that line represents the infinite amount of answers. So let me skip over the vocabulary right now and let's jump right into solving a system of equations, right? So we have a system right here, and like we said, a system is really just 2 or more equations working together. And what we need to do is find the x and the y value that not only work for one, but works for the entire system because they're working together, all right? So we need to get the answer x, y values that works for both the top equation and the bottom equation. So instead of starting to guess, oh, let's say x is 2, then what would y be? And then see if it works down here with x and y. Instead of wasting our time by guessing and checking, we're going to use what we know, that if we graph it, the line represents all the answers. And if we graph the other one, that other line will represent the other answers. And to find that one answer that works for both, all we have to do is find the point of intersection. So let's begin with the top one, and let me graph it in red. It's already in slope-intercept form. So let's put our y-intercept value at -2. Let's put a dot right there. From that point, I'm going to drop 3 and run 1 because my slope is -3/1. Remember, you want it to be a fraction, so put it over 1. So -3/1, you're going to be going down 3, 1, 2, 3 to the edge over 1. You always go over, you always run to the right from left to right, okay? So let's put a dot right there, and you could use that same pattern of down 3/1 backwards, over 1, up 3, over 1, up 3, and put a dot right there. And you could continue over 1, up 3, put a dot right there to make that as long as you need it to be. So there's my line. That red line represents all the infinite answers that exist to this top equation that I just boxed in red. Okay, so let's look at the bottom equation. Now the bottom equation, I want to graph it in blue. Now, there's many different ways of graphing. You could use an XY table, plug in values for X, pull out values for Y. You could use, since it's in standard form, you could do the x-intercept by setting y equal to 0 and then finding the x-intercept. And then to find the y-intercept, you set x equal to 0. But I'm just going to stick to y equals mx plus b. So let's get rid of the 2x. Let's get y by itself on the left side of the equal sign. So we're going to get rid of the 2x by subtracting it. What I do to one side, I do to the other. Let me rewrite. I have 3y equals, of course, you want to write your x term first. So that's a -2x, and the above 6 is negative. So I rewrite it as -2x plus, or minus 6. Final step would be to divide everything by 3, divide by 3, divide by 3, divide by 3. I will get y equals -2/3 x minus 2. So now that it's in slope-intercept form, I know that it crosses the y-axis at -2, and I know that it has the slope of 2/3, right? So let's put a dot at -2 on the y, and notice it's the same exact y-intercept as the above equation. And if I did go down 2 over 3, down 1, 2 over 1, 2, 3, I'd get to that point right there. And I could go backwards to extend it the other way. And I have my line. And of course it has arrows because there's an infinite amount of answers. Now once again, the red line represents the infinite amount of answers that exist to the top equation. The blue line represents the infinite amount of answers that exist to this bottom equation. Maybe I shouldn't have done that. Let me start. Sorry. And if you want that one single answer that works for the entire system, the one single answer that works for the entire system, obviously you want the point of intersection, which is right here. And that point of intersection happens to be 0 on the x, negative 2 on the y. So let's write that down, that the answer must be 0, negative 2. Why is that? Because that's the only point that they share. Now, what does that mean in terms of the system? That means that your x value is 0 and your y value is negative 2. That's the only pair of numbers that'll give you a true statement in both the top equation and the bottom equation. That works for both. There is no other pair of numbers in the world that you could plug in that would work for both the top and bottom equation on this system. Now, let's say you're taking a quiz and you have some time left over. Don't just say that that's your answer. Double check it, right? So let's double check it on the top equation. It says y equals, instead of y, I want to put negative 2. So on the top equation, it's going to say negative 2 equals negative 3 times x, and we see that x is going to be 0 in this case, so let's put a 0 in there. And then we have a minus 2, so let's put a minus 2 right there. Now let's see if that's a true statement. What's negative 3 times 0? That's 0. And then 0 minus 2, yeah, it really is negative 2. So we have double checked that top equation. Now let's go for the bottom equation. 2x, that would be 2 times 0. That's pretty easy to do, 2 times 0. And then we have plus 3y, so that would be 3 times negative 2, right? Plus 3 times negative 2. And it says right here that it should equal negative 6. So let's write it down. It should equal negative 6. And of course, 2 times 0 disappears. And 3 times negative 2 really is negative 6. So we have double checked the bottom equation. So it's not, it's important to be able to graph correctly. And then once you find that answer, double check it by plugging in your x right there and plugging in your y right there on both equations to double check and be absolutely positive that you got the right answer on the quiz or test, or homework for that matter. So all this is about graphing. That's why we spent one day yesterday on reviewing graphing with y equals mx plus b. Let's graph number 2 here. The top equation, if I wanted to graph it with y equals mx plus b, I have to get y by itself. So I'd have to add 2x and add 2x. So I'd have a new equation that reads y equals positive 2x minus 3. Now that that's in slope-intercept form, I could clearly see that my slope is 2, and I want it in the form of a fraction, so I'll put it as 2 over 1. And my y-intercept is negative 3, and you always start with the y-intercept of negative 3. So let's go to the y-axis, let's go to negative 3, let's put a dot right there. And from the y value of negative 3, I need to rise and run according to my slope. So I'm going to rise 2 and run 1. Rise 1, 2, and run 1, and put a dot right here. And then I continue to rise 2, run 1, rise 2, run 1. I could even use that pattern backwards to extend it the other way, but this is my line. Okay, let's go to the other equation. The other equation, I want to graph it in red. It's already, this one right here, it's already in slope-intercept form. So it crosses at positive 2. I got that from my b value here. And then I'm going to go down 3 over 1. Again, make it look like a fraction, put it over 1. So I'm going to go down 1, 2, 3 over 1, and guess what? I end up at that same exact coordinate of 1, negative 1. And you could continue to go down 3 over 1, and you could use the pattern backwards to extend it the other way. But remember, all we're trying to do is find that one single answer that works for both top and bottom equation. So that would be this point of intersection right here, which would be the coordinate 1 on the x, negative 1 on the y. And of course, if you wanted to double check it, you'd say x is 1, put a 1 right there. Negative 2 times 1 is negative 2. And then negative 1 right here. So negative 2 plus negative 1, that really is negative 3. So it works on the top equation. I've double checked the top equation. Now let's double check the bottom equation. X is 1, put a 1 right there. Y is negative 1, put a negative 1 over there. So it would read negative 1 equals negative 3 times 1 is negative 3. So negative 1 equals negative 3 plus 2. Negative 1, it really does equal negative 1 because negative 3 plus 2 is negative 1. Of course, I could be showing my work to all this, but there's my answer, 1, negative 1. Now, the question is, will we always be able to find one answer? The answer to that is no. Because sometimes, I mean, if you're saying you're always going to be able to find a point of intersection, it's not true. Because sometimes you might end up with parallel lines that never cross, which means that there would be no solution. Sometimes you might end up with the same exact line, which means that they would land perfectly on top of each other, which means that there would be an infinite amount of solutions because we're looking for that point that they share, and if they're sharing all the points, then there's an infinite amount of answers that work for both. Let me give you, let's jump to number 4. I'll give you an example of this. Number 4, I already know that they're both in slope-intercept form. I already know that they both have the same slope. So if they have the same slope, I know they're parallel. I know they're not going to intersect. Let me just show you. Top equation crosses at 3. It goes up 2 over 1. There it goes. And you could use that pattern backwards all the way to extend it. Okay. And then the bottom equation I'm going to do in red, it crosses at negative 5, way at the edge, and it goes up 2 over 1. Extend it all the way through. And as you could see, the red line is parallel to the blue line. So if I'm trying to find that one answer, that one point that works for both the top equation and the bottom equation, by the way, the top equation I did in red, the bottom equation I did in blue, I'm trying to find the point that they share, the point of intersection. These guys are never going to cross. They're never going to cross. So what do I say? If I'm trying to find the answer and they never cross, then there is no answer. So you would say no solution. Yeah, I know. That's kind of weird. But still, there is no answer. Remember, what is the answer? It's the point that they share, a point of intersection. If they don't cross, then there is no solution. Now let's take a look at this one right here. Number 5, let's get them both in slope-intercept form. So on the top equation, we're going to divide everything by 2, and I will get a new equation that reads y equals a divided by 2 is 4x plus 6. And the bottom equation I'm going to do in red, I need to get y by itself, so I'm going to go plus 4x, and I will have y equals 4x plus 6. And then at this point, you should be like, wait a minute, this equation in blue is the same exact equation as this one in red. So if I graphed it, it would be the same exact line. I know even if we were to graph this, it'd be kind of weird. The top one, it crosses at 6. That's 1 point off the graph. Instead of going up 4 over 1, I want to go backwards. I want to go down 1, 2, 3, 4 over 1. And I'll get the point right there. And then down 1, 2, 3, 4 over 1, extending it all the way. Here's my blue line. And if I were to graph the red line, it would be the same exact line right on top of each other. Okay? So if the goal of solving a system by graphing is to find the point that they share, the point of intersection, and we ask ourselves, which point do they share? Well, they share all the points. How many points is that? It's an infinite amount of points that they share. So right here, the correct response would be that there's an infinitely many solutions. There you go, infinitely many solutions. Okay, so once again, you're going to have most of them, you're going to be able to find an answer. This answer is 1, negative 1, because there is a point of intersection. But there's these rare cases, sometimes they don't cross at all. They're parallel. And that's right there, you don't have any solution. And sometimes, rare case also, you end up with the same equation which produces the same line, which means that there's an infinite amount of points that they share. So you would say infinitely many solutions. Okay, that kind of leads us to, or brings us back to the vocabulary over here. there's two types of systems. There's when they ask you to classify, that is. There's consistent systems. That means that there is a solution or solutions. They do exist. And there's two kinds of consistent systems. There's consistent independent, which means one single answer, and there's consistent dependent, which means that there's an infinite amount of answers. Okay? So, for example, this guy up here, number 2, that is what we would call a consistent system because there is an answer. And there's only one answer, so it would actually be a consistent independent, right? Consistent independent system, okay? That's if they ask you to classify. Down here, this would be, as you read over here, it says inconsistent, there is no solution. They do not intersect, they're parallel. Lines do not have any points in common. So down here, this one, number 4, this is what we would call an inconsistent system. That's only if they ask you to classify, right? Might as well do this last one that we haven't done yet. By the way, that inconsistent and consistent, I have some notes right here for you. Tips, sometimes you don't even have to graph. If you're rewriting equations in y equals mx plus b form and you notice that the m's are exactly the same, you know they're parallel, right? Which means they don't intersect, which means that there's no solutions. So if you're trying to solve it, you would just say no solution. If they ask you to classify it, you would say it's an inconsistent system, okay? Or if you're rewriting it in slope-intercept form and it's the same exact identical equation, then you would say it's consistent dependent, right? Now the answer to that, that's a classifying, like they tell you to classify, you would say consistent dependent. But if they ask you for the solution to solve it, you would say infinitely many solutions, kind of like we did down here. Let's do this last one. I hope you guys remember that when you have a letter equaling a number, you just go to that axis, you go to that value, and you draw a line right through it. So y equals -1. Let's go to the -1 on the y, and let's draw a line right through it. There is my equation up here in red. Okay. Now let's do the bottom equation in blue. Let me solve for y to get in y equals mx plus b form. So I would subtract 3x. Y equals -3x plus 5. And let's graph by putting the y-intercept value at 5 right here on the edge. And of course it's going to go down 3 over 1. So if I do go down 3, 1, 2, 3 over 1, I get there. 1, 2, 3 over 1, I get there, and so on and so on. But as you can see, the blue line will cross right there at that coordinate. This coordinate right here. What is that coordinate? That is the coordinate 2 on the x, -1 on the y. So the answer to this system up here, both equations, is 2 on the x, -1 on the y. If you wanted to double check it, all you have to do is plug in your x value into the x's and the y value into the y's. Okay, so if I did plug in 2 right here, it'd be 3 times 2, that's 6. Plug in a -1 right here. What's 6 plus -1? That really is 5. You've double checked it. And if you were to plug in the 2 for x on the top one, hey, there is no x. Okay, so we don't have to. Plug in the -1 for y right there. It'll say -1 equals -1, and that is also a true statement. You've double checked it. That's your correct answer to that system. You could bet your life on it. Anyhow, solving systems of equations by graphing. I hope you understand it. Next week we're going to be learning different methods on solving systems, which are even better than solving by graphing.